Now we are going to look at the other part of Chapter 20 on input devices. The two most common input devices for computers are the keyboard and a pointing device, which on a desktop system is generally a mouse. For laptop computers, it's a touchpad. Most keyboards operate using similar technology. They use switches and circuits to translate a person's keystrokes into a signal a computer can understand. Keyboards can have different keys depending on the manufacturer, the operating system they're designed for, and whether they're attached to a desktop computer or part of a laptop. But for the most part, these keys, also called keycaps, are the same size and shape from keyboard to keyboard. They're also placed at a similar distance from one another in a similar pattern, no matter what language or alphabet the keys represent. Most keyboards have between 80 and 110 keys, including typing keys, a numeric keypad, function keys, and control keys. The Windows keyboards add some extra control keys, 2 Windows or Start keys, and an application key. A keyboard is a lot like a miniature computer. It has its own small processor and circuitry that carries information to and from that processor. A large part of this circuitry makes up the key matrix. The key matrix is a grid of circuits underneath the keys. Each circuit is broken at a point below each key. When you press a key, it presses a switch, which completes the circuit and allows a tiny amount of current to flow through. The mechanical action of the switch causes some vibration, called bounce, which the processor filters out. If you press and hold a key, the processor recognizes it as the equivalent of pressing a key repeatedly. As you type, the processor in the keyboard analyzes the key matrix and determines what characters to send to the computer. It maintains these characters in its memory buffer, and then it sends the data. Many keyboards connect to the computer through a cable with a PS2 or USB connector. Laptops use internal connectors. Regardless of which type of connector is used, the cable must carry power to the keyboard, and it must carry signals from the keyboard back to the computer. Wireless keyboards, on the other hand, connect to the computer through infrared, radio frequency, or Bluetooth connections. Regardless of which sort of signal they use, wireless keyboards require a receiver, either built into the computer or plugged into the USB port, in order to communicate with the computer. Since they don't have a physical connection to the computer, wireless keyboards have an AC power connection or use batteries for power. Whether it's through a cable or wireless, the signal from the keyboard is monitored by the computer's keyboard controller. This is an integrated circuit that processes all of the data that comes from the keyboard and forwards it to the operating system. When the operating system is notified that there is data from the keyboard, it checks to see if the keyboard data is a system-level command. A good example of this is Control-Alt-Delete for a Windows computer, which reboots the system. Then the operating system passes the keyboard data onto the current application. The application determines whether the keyboard data is a command like Alt-F, which opens the file menu in a Windows application. If the data is not a command, the application accepts it as content, which can be anything from typing a document to entering a URL to performing a calculation. If the current application does not accept keyboard data, it simply ignores the information. This whole process, from pressing the key to entering content into an application, happens almost instantaneously. Windows can be used without a mouse, but this requires knowing the navigation hotkeys for the operating system. So mice definitely make some tasks easier. Standard mouse drivers are included with Windows, but specialty mice have their own drivers, and mice can be configured in the Mouse Control Panel applet. Mice using a ball technology have been nearly completely replaced with optical technology mice. These use LEDs or lasers and a camera to track their movements. These mice need little maintenance or cleaning, although you may occasionally want to clean the optics area. Historically, corded mice have been more responsive than wireless mice. This fact is changing, however, with the advent of improvements in wireless technologies and optical sensors. Other factors that affect quality include the size of the optical sensor. Larger is generally better, assuming the other mouse components can handle the larger size. Sizes range from 16 by 16 pixels to 30 by 30 pixels. The refresh rate. This is how often the sensor samples images as you move the mouse. Faster is generally better, assuming other mouse components can process them. Rates range from 1,500 to 6,000 samples per second. Image processing rate. This is a combination of the size of the optical sensor and the refresh rate. Again, faster is better, and rates range from 0.486 to 5.8 megapixels per second. Maximum speed. This is the maximum speed that you can move the mouse and obtain accurate tracking. Again, faster is better. Rates range from 16 to 40 inches per second. Most wireless mice use radio frequency technology to communicate information to your computer. Being radio-based, RF devices require two main components, a transmitter and a receiver. Here's how it works. The transmitter is housed in the mouse. It sends an electromagnetic or radio signal that encodes the information about the mouse's movements and the buttons you click. The receiver, which is connected to your computer, accepts the signal, decodes it, and passes it on to the mouse driver software and your computer's operating system. The receiver can be a separate device that plugs into your computer, a special card that you put in an expansion slot, or a built-in component. One of the RF technologies that wireless mice commonly use is Bluetooth. Bluetooth devices have a range of about 33 feet or 10 meters. As with many computer-related devices, mice are being combined with other gadgets and technologies to create improved and multi-purpose devices. Examples include multimedia mice, combination mice remote controls, gaming mice, biometric mice, tilting wheel mice, and motion-based mice. Now let's look at scanners. These vary in resolution and sharpness. Excuse me. I apologize, brief technical difficulty there. The basic principle of a scanner is to analyze an image and process it in some way. Image and text capture, or optical character recognition, allow you to save information to a file on your computer. You can then alter or enhance the image, print it out, or use it on a web page. The core component of the scanner is the charge coupled device, or CCD array. CCD is a collection of tiny light-sensitive diodes which convert photons, or light, into electrons, or an electrical charge. These diodes are called photosites. Each photosite is sensitive to light. The brighter the light that hits a single photosite, the greater the electrical charge that will accumulate at that site. The image of the document that you scan reaches the CCD array through a series of mirrors, filters, and lenses. The exact configuration of these components will depend on the model of scanner, but the basics are pretty much the same. Scanners vary in resolution and sharpness. Most flatbed scanners have a true hardware resolution of at least 300 by 300 dots per inch. The scanner's DPI is determined by the number of sensors in a single row of the array by the precision of the stepper motor. Sharpness depends mainly on the quality of the optics used to make the lens and the brightness of the light source. A bright xenon lamp and high-quality lens will create a much clearer and therefore sharper image than a standard fluorescent lamp and basic lens. Another term used when talking about scanners is bit depth, which is also called color depth. This simply refers to the number of colors that the scanner is capable of reproducing. Each pixel requires 24 bits to create standard true color, and virtually all scanners on the market support this. Many of them offer bit depths of 30 or 36 bits. They still only output in 24-bit color, but perform internal processing to select the best possible choice out of the colors available in the increased palette. There are many opinions about whether there is a noticeable difference in quality between 24, 30, and 36-bit scanners. Scanning the document is only one part of the process. For the scanned image to be useful, it must be transferred to your computer. On your computer, you need a driver that knows how to communicate with the scanners. Most scanners speak a common language called Twain. Twain is actually known as technology without an interesting name. The Twain driver acts as the interpreter between any application that supports the Twain standard and the scanner. This means that the application does not need to know the specific details of the scanner in order to access it directly. For example, you can choose to acquire an image from the scanner from within Adobe Photoshop because Photoshop supports the Twain standard. In addition to the driver, most scanners come with other software. Typically, a scanning utility and some type of image editing application are included. A lot of scanners include OCR software. OCR allows you to scan in words from a document and convert them into computer-based text. It uses an averaging process to determine what the shape of a character is and match it to the correct letter or number. Biometric devices are used by computers for security. They scan and remember unique aspects of your retina, your iris, or fingerprint by using a scanning device. This is then used to secure a particular device. Some are devices that secure entire computers by replacing the username, password security commonly used. These devices are also used for recognition, such as voice recognition. It's common in devices such as smartphones that have a limited number of commands to interpret. Barcode readers are designed to read the standard UPC barcodes used to track inventory. There are two common types used with PCs, either the pen scanner or the hand scanner. Touch screens are monitors with some type of sensing device that detects the location and the duration of contact. This contact is then interpreted as though it were a click event of a mouse. These are commonly found on smartphones, tablets, point-of-sale systems, and information kiosks. Newer versions of Windows include control panel applets to configure the touch screens on tablet PCs. A keyboard, video, mouse or KVM switch lets multiple computers be viewed and controlled by a single set of peripherals. They are often used with rack-mounted servers. There are different types of KVM switches. Some control a couple systems, some support hundreds. Once connected to the systems being controlled, hotkeys let you toggle between those systems. Gamepads and joysticks are commonly used with PC games, though today many are controlled by the mouse and keyboard. Those games designed to be played on console systems often require a gamepad. These devices can be configured in the appropriate operating system applet. Digitizers let users paint or draw on a computer by using a stylus on a special surface. The computer uses software to turn this input into an image on screen. A common type of this device is used to capture a signature electronically for transmission over the internet. The digital camera is so truly different from its analog predecessor. All digital cameras have a built-in computer, and all of them record images electronically. Essentially, a digital image is just a long string of zeros and ones that represent all the tiny colored dots or pixels that collectively make up that image. You can directly sample the original light that bounces off of your subject, immediately breaking that light pattern down into a series of pixel values. At its most basic level, this is all there is to a digital camera. Just like a conventional camera, it has a series of lenses that focus light to create an image of a scene. But instead of focusing this light onto a piece of film, it focuses it onto a semiconductor device that records light electronically. A computer then breaks this electronic information down into digital data. All of the fun and interesting features of digital cameras come as a direct result of this process. The amount of detail that the camera can capture is called the resolution, and it is measured in pixels. The more pixels a camera has, the more detail it can capture, and the larger the pictures can be without becoming blurry or grainy. A couple of useful terms. Aperture is the size of the opening in the camera. The aperture is automatic in most digital cameras, but some allow manual adjustment to give professionals and hobbyists more control over the final image. Shutter speed is the amount of time that light can pass through the aperture. Unlike film, the light sensor in a digital camera can be reset electronically, so digital cameras have a digital shutter rather than a mechanical shutter. These two aspects work together to capture the amount of light needed to make a good image. In photographic terms, they set the exposure of the sensor. In addition to controlling the amount of light, the camera has to adjust the lenses to control how the light is focused on the sensor. In general, the lenses on digital cameras are very similar to conventional camera lenses. Some digital cameras can even use conventional lenses. The focal length, however, is one important difference between the lens of a digital camera and the lens of a 35mm camera. The focal length is the distance between the lens and the surface of the sensor. Sensors from different manufacturers vary widely in size, but in general they're smaller than a piece of 35mm film. In order to project the image onto a smaller sensor, the focal length is shortened by the same proportion. Focal length also determines the magnification, or zoom, when you look through the camera. Increasing the focal length increases the magnification, and objects appear to get closer. The reverse happens when decreasing the focal length. A zoom lens is any lens that has an adjustable focal length, and digital cameras can have optical or digital zoom, Some have both. Some cameras also have macro focusing capability, meaning the camera can take pictures from very close to the subject. A simple webcam setup consists of a digital camera attached to your computer, usually through the USB port. The camera part of the webcam setup is just a digital camera. There's really nothing special going on there. Excuse me. The webcam nature of the camera comes with the software. Webcam software grabs a frame from the digital camera at a preset interval. For example, the software might grab a still image from the camera once every 30 seconds and transfers it to another location for viewing. If you're interested in using your webcam for streaming video, you'll need to have a webcam system with a high frame rate. Frame rate indicates the number of pictures the software can grab and transfer in 1 second. For streaming video, you'll need a minimum rate of at least 15 frames per second, and 30 frames per second is ideal. To achieve high frame rates, you need a high-speed internet connection. Once it captures a frame, the software broadcasts the image over your internet connection. There are several broadcast methods. Using the most common method, the software turns that image into a JPEG file and uploads it to a web server using File Transfer Protocol, or FTP. You can then easily place a JPEG image onto any web page. This concludes our discussion of input devices.